Okay, so we're on to part 2 now of our tick by distance function. So the first thing we want to do then is we want to make a function library here. So function library. What am I doing? Function library, here we go. So we want to call this audio function library. Now what a function library does for us is it allows us to make a function and we can basically have the information in one place and then use it in many blueprints. And if we make a change in this function library, you know, anything that's referenced in this function will get those changes as well. So as long as you can use function libraries, like with world objects, you can't use function libraries necessarily. You might have to use a macro library, but it's the same kind of concept essentially. So let's call this tick by distance. And then in here, we want to not use this anymore. And we're going to say tick by distance. And you can see that the audio function library shows here. Let's just get that hooked up for now. And then what we want in here is we want to have two inputs. Both are floats, and this one is going to be called distance in, and this one would be called map in, because we're going to use a map to we're going to pair some values together basically. This is a map or a dictionary. Some people call them dictionaries for other languages, but with blueprints they are called maps. So the first thing we want to do then is we want to iterate over the keys. So let's do keys, and we want a for loop with break. It doesn't have to be a break, but it should be a break, and we'll discuss that a little later on. Distance in, we want to basically check, is our distance in less than something? Bunch. And if it is, we will break. So basically what we're going to do is we're going to iterate over this map, and if we find our distance, then we will break the loop, because we don't need to loop, we don't need to keep iterating if we found our value. We're going to want to get from our keys from this index there, and that is what we're going to check for our distance in. Okay, so we provide a distance in, which will come from our distance to spline parameter. We will provide a map in, get the keys, iterate over them until our distance in is less than something in our map. And then we need to return that result, don't we? So let's say tick interval out. That's okay. Yeah. And we want to do that when we have our, when we've broken our loop or completed it, that is when we provide this. And it wants to be a single value float. So one thing we need to consider then is, what if we don't give it a map? We need a fallback value, right? So we want to say is not empty. And we're going to find from our map. So is our, yeah, this, yeah. And we want to make a variable here, and we want to call it default tick. Default tick. So essentially what we're going to do here is we're going to provide a default fallback value in case a map wasn't passed in as a variable. And we're going to select here. So if our map is not empty, which means will be true, we will pass this, we'll pass in what this finds. If it is empty, we will we're going to return our default tick to our return node. And then let's see here then. So back to our spline blueprint. What we want to do here is we need to get our distance. We need to give that in. And we need to make a map. So we're going to say if our distance is less than 500, we're going to provide a value of 0.016. If we are less than 1000, 0.032. If we're less than 2000, 0.5. So now we can scale this, you know, as much as we want to. Obviously, each time you do that, it costs, it costs to do that. So, but the point of this is that we can scale this, and you can even build on top of it in terms of levels of quality. So, you know, maybe some things have like a level of quality 1, where they, you know, don't have as much, you know, there's not as much need for distance, and then some things might have a need for it that are, you know, scaled differently. So back in here then, we get our keys, we check if our distance is less than one of those keys, then we find it and return that value out. Okay, and what we want to do then is when we get this, we want to set our tick interval so that we can see in our debugging what the interval actually is. And we want to act a tick interval as well. This is how we actually scale it, yeah. And then on our debugging, let's just add tick interval here, because just to make sure that we get the right, we want to make sure that we're doing the correct thing here and it actually works. So we are over 2000, and that's the cool thing about the map as well, is if you're not under it, it's still going to use the highest index like value, so you don't have to account for under and over. Like if you're over it, it's still going to get the highest value there. And then when I pass under 2000 here, we are still at 0.5. When I pass under 1000, we are now at 0.032. Back over again, we can see that it's scaling with us. And then pass under 500, 0.016. So now we have a fully scaling TickByDistance function. That is in a function library. So like I said, if we change anything in here, if we want to build on top of this, if we want to remove something, then anywhere that it's used, i.e. here, we'll get those changes as well. So there we have it. TickByDistance.